In rotating plane method, actually what we or plane rotation method or trapezoidal method, what we consider is we consider a plane which involves the front view as well as our true line, our actual line, or the second condition, that is the top view and the true line. So these two different planes will be there. So we rotate these two different planes so that this plane coincides with our HP or coincides with our VP, depending on the condition, depending on which view we are considering. So using these two lines, that is our front view and our actual line, if we consider a quadrilateral as these two sides, the front view and the actual line as opposite sides, it will form a trapezoid. Or that's why this method is known as a trapezoidal method. It actually forms a trapezium in which the two projectors are the parallel sides, and the other two sides are not non-parallel sides. So then we rotate this particular trapezoid in such a way, or trapezium in such a way, that the edge which is the front view is one edge and it remains in its position itself. All the other three edges rotate. So that's the method of plane rotation. In this method, actually what we do is we rotate a plane, not the actual line. That is why this is known as the plane rotation method. Let's visualize it, how it is being done. So this is our HP and VP as usual. The usual notations are used. HP is here and VP is here, and here it is, the XY line is here. Now this is our actual line AB. The original line AB is lying in such a way that it is inclined to both HP and VP. It makes some angle theta with the HP and some angle phi with the VP. So that is our actual line. Now we obtain the front view of the line. So in order to get the front view, we actually project the point A perpendicular to the VP and the point B perpendicular to VP. Actually, here is a line. It seems to be, it is not that visible. The color of that particular line is I gave it as a green, so that is not that visible. From B to B dash there is a line. So now we join A dash and B dash in order to get our front view. So this is our front view. Now in order to get the top view, again we project our usual procedure. We project A and B perpendicular to the HP. So A and B is obtained, and then we join it using a straight line AB. So this is the arrangement. This is the actual arrangement in which we obtain the front view as well as the top view. And now what we do is we actually join A dash with XY line and A with the XY line in order to get the projector lines. So this is the method. This is how we complete our normal projection procedure, our orthographic projection procedure. Now, if we extend this AB line towards the vertical plane, here we will get VT. That is the point in which the actual line intersects with our vertical plane. So that is the point VT. And from VT we can obtain the point V. The point V is obtained as the line which is, the point which is obtained by the point at the intersection of our top view with our XY line. So point V is obtained. Likewise, we can obtain the HT also, the horizontal trace. That is when the line is extended, the actual line is extended, when it intersects with our HP. This is the point HT, and the H dash is also obtained. H dash is the point of intersection of the front view and the XY line. This much concept is clear to us. Then these entire things is clear to us. Now what we consider is when we know that when A dash B dash is extended, it passes through VT. This is our concept that we have already seen in our line rotation method. When A dash B dash is extended, it passes through VT, that is the point H dash, A dash, B dash, and VT are in the same line. That also we have seen. And likewise, so that particular inclination, this inclination will be the true inclination of the line with the VP. It is the vertical, true inclination with the vertical plane can be marked here. So likewise, here also the HT also, when the point AB is extended or the line AB is extended, it passes through HT. This also we have already seen, that is when in the top view, V, A, B and HT are in the same line. So that also we have seen. And the inclination of the actual line with the VP, HP, that is the true inclination with the HP. So theta is also obtained. So now what we consider is, we consider a plane, this shaded area. This is actually a plane, a trapezium in which AB, BA, that is capital AB and small BA are the four corners. In this one, this BB as well as AA are the parallel sides that you know. These two are parallel sides. Why these are parallel sides? These are perpendicular to the HP. Any line which is perpendicular to the HP should be parallel to any other such line, any other such perpendicular. So this line, this AB, BB as well as BA, AA, capital A, small a, capital B, small b. These two sides are parallel, but these AB, capital AB as well as small letter AB, these two are not parallel lines. So this is a trapezium, a plane. This is the trapezium that we consider, or this is the plane which we rotate. So now there is another plane here. If you consider A, B, B dash and A dash, there is another plane. Before that, let us rotate this particular plane. If we rotate this particular plane such that this particular plane coincides with our HP, it coincides with HP, it will be like this. It will be like this, and this will be the true length, because this line is of true length, our actual line. It coincides with this true length line, or this line, this AA2, small letter AA2 line should be perpendicular to AB, small letter AB. Why it is perpendicular? Because this one is perpendicular, AA is perpendicular, so AA2 should also be perpendicular to AB. Likewise, BB2 should be perpendicular to BB. So likewise, we are rotating it. That is why this is known as rotating plane method. In this one, actually, we are rotating a plane, this particular plane or this particular planar figure, trapezium. It is rotated. That is the method. Now, this line, this AB2 should be of having true length. It should be of true length. Now we consider another plane, the second plane, that is A dash, B dash, B. This is our second plane. And this plane also, if we rotate this plane also, it will also give you a similar figure like this. A similar figure like this, that is a trapezium, which is lying in VP. Here it is was lying in HP. If this particular plane is being rotated, then it should be in the opposite direction. So like this, in this direction, it is being rotated like here, in this direction. So this is being rotated, and this plane becomes a plane like this, a planar figure like this. So this is the true. This again, this A1, B1, this should also give you the true length. Why it should give you the true length? Because this edge of this particular plane, this particular trapezium, this edge represents the true length. This edge represents the top front view length. This edge AB represents the top view length. So since this one is the true length, when it is rotated like this, it should be the true length. So this A1, B1 should be true length. Now, if we extend this AB2, the line A2, B2 towards the HT side, it should also pass through HT. And this angle AB makes with the A2, B2 at the HT. This angle should be theta. since we are rotating this particular triangular figure or triangular shape, if we are considering not just this trapezium, instead if we consider this entire triangle including HT, if we rotate it, then here also we will get a triangle, the same triangle. So in that case, HT is lying in the same line as A2, B2 as well as AB. So the line of point of intersection of AB with the A2, B2 will give you the HT, and the inclination will give you the true inclination with the HP, that is theta. So the similar condition is here also. Here also we can consider this A dash VT as a triangle, and that particular triangle is rotated in order to obtain A dash A1 VT. So this one, this A dash A1 VT. So these two triangles will be same. Here in the top it remains dissimilar in appearance just because we are representing it in 3 dimensions. Since it is being represented in 3 dimensions, it appears slightly different. And here it is not that different because these two lines becomes almost in the same straight line. So that's why it is the dissimilarity feels. Actually, it should be, if you consider the entire 3-dimensional picture, then this picture, this shape should be equal to this shape, as well as this shape should be equal to this shape. So that is the condition. Now this angle, this phi, this angle is the inclination, that is the inclination between A dash B dash and A1 B1. It should be equal to phi, the true inclination with the VP. So that's it. Now if we remove the unwanted things like our actual line, the planes, etc. from the figure, we remove the actual line and the because in the actual line and the planes are only in the 3-dimensional representation, not in our 2-dimensional representation. 2 dimensions, the planes cannot be, or the actual line cannot be shown in 2-dimensional representation, that is our projection. What we see is only the front view and the top view, not the actual line. So what we remove that particular things, only the drawings that is available in our HP and VP is now represented. Only the drawings that is available in our HP and VP is now represented. Now we can convert this one. Now what we do is we rotate HP 90-degree clockwise direction or 90-degree downward direction. That is, in this direction we rotate our HP so that the entire thing becomes in the same figure, I mean in the same plane. So it will be like this. So this will be the entire shape that is remaining, or the shape that is available in 2 dimensions. Now if we remove the VP and the HP also, the entire figure will be like this. In this case, this distance A dash B dash, that is the top view, sorry, I mean front view, and AB is the top view, and A2 B2 is the true length, A1 B1 is also the true length. This is the vertical rays V and H dash HT, and here you will get theta, that is the true inclination with the HP, and here you will get the true inclination with the VP. This is the condition. Now in this figure, if you consider this distance, let me give you, this distance should be equal to this distance. As in our previous representation we have seen, I can show it to you. Here, see, this distance should be equal to this distance. These 2 distances should be same, should not be any difference. Likewise, this distance should be equal to this distance, which should be equal to this distance. That is, this distance should be equal to this distance. So in this case, this one, and this one, these 3 distances are same. Likewise, here I am using another notation. This one, and this one. These 3 distances are same. Here also, this distance, the rectangular marked distance, this, and here, this is another distance which is actually behind the plane, so it is not that visible. This distance, these 3 distances are same. And here also, this distance as well as this distance and this distance. this distance. All these three distances are same. This one, and this one. So the condition is that this distance, this B2 distance should be equal to the distance of B dash from XY line. B2, the distance of B dash from XY line, this distance. Likewise, the B dash B1 distance, that is the distance of point B from the XY line in top view. Likewise, A dash A1 distance, the distance of A from XY line in top view. The distance A2 distance, that is the distance of A dash from XY line. So likewise, there is a correlation between the distances, the projection distances, so that we can see in the final figure. See, this distance equal to this distance. This distance should be equal to this distance. And here, this distance is equal to this distance. And this distance equal to this distance. This is the condition. So this is the condition where the distance of A dash from XY is equal to the distance of A from A2. The distance of A from XY line is equal to the distance A1 A dash. The distance of B dash from XY line is equal to the distance B2. The distance of B from XY line is equal to the distance B1 B dash. So this is another reference figure or base figure which is used for our plane rotation method. This one is used for the plane rotation method. In this case, this is the true length. Here it is the top front view length. This is front view length, and this is the top view length. And the alpha value. Alpha is the inclination of the front view with the XY line. So this is alpha. The inclination of VP with, the inclination of XY with the top view. This is beta. And theta is here. In the top view you obtain HT, and in HT you obtain the theta. And in front view you obtain VT, and in VT you obtain the phi, that is the true inclination with the VP. So this is how the the plane rotation method is drawn. Comparatively, compared to the other figure, this is a simpler one. The only difficulty is that when the true inclinations and the true length are given, when the true inclinations and the true length are completely given, it is very difficult for us to draw this method using this particular plane rotation method. But when the projections are completely given, that is both the endpoints A dash and B dash, the position of A dash A, B dash B, and the distance between the projectors are given. This one is slightly similar in the sense the drawing will be bit neater than, it won't be any arc involved in this one. So in some problems, it is always better to go for this one, or but all the problems can be done using the line rotation method with a slight modifications wherever it is necessary. But the plane rotation method can be used for some specific problems, some special problems in which the actual projections are given in a better manner. So we can see some of such problems after a 5 minutes break. Okay, I hope you understood. Any doubts? Okay, this is our actual line. What we do is we obtain the front view here and the top view here, and the VT, V, HT, H dash, etc. These are our common figures or common things in three-dimensional representation. This is what you right now see is the three-dimensional representation. Now, what we consider is we consider a plane involving the front view as involving the top view and the actual line. One end of or one side of this particular plane is or planar figure, not a complete plane. We are considering only a planar figure. The shape of the figure is a trapezium. So in this particular trapezium, one side is AB, that is our actual line, the capital AB, and the opposite side is our top view, that is our small letter AB. Now what we do is we rotate this particular trapezium in such a way that it falls on or it lies completely on our HP. So like this direction, we rotate it such that it completely lies in our HP. Now, if you consider this distance should be equal to this distance, this edge, and this distance is equal to this distance. So that is the distance of B dash from XY line is marked as B2. So that is the condition. Now this A to B2 is our true length, and AB is our top view. Likewise, you can consider another plane in which the front view as well as the actual line is involved. The front view as well as our actual line is involved. Here A dash, B dash is our front view and AB is our actual line. Now this particular plane is rotated in such a way that that particular plane, this particular trapezium, the planar figure, it is a planar figure, not an entire plane. That planar figure, trapezium, is completely lying in VP, like this. So now this line, this dark line, A1, B1 will give you the true length. So this is the procedure by which we rotate the plane. No, we are rotating a plane here, not a line here. That is why this is a plane rotation. Now here also, this distance, A dash A1 distance is equal to A dash distance. And the A dash distance is equal to the distance of A from XY line. So likewise, this distance, B1 B dash distance, that distance is equal to B dash B distance, or it should be equal to the same distance as B from XY, the distance of B from XY line. So this is, in this case, the distances are having a relation. So then here you can obtain phi. Phi is the point, the angle which is made by the true length line. True length line in this case is A1 B1 with the A dash B dash at VT, and the theta is obtained as the inclination between the lines AB, that is the top view, and the true length line in top view, that is the A to B2 in HT. So this is how it is being obtained. Now we remove everything that is not necessary or not lying in our HP and VP. Every lines, every planes, etc., which are not lying in our HP and VP are removed. Then we convert this particular HP, or we rotate the HP 90-degree clockwise, so that HP and VP will lie in the same vertical plane or in the same plane, separated by the XY line. So like this. Now we remove our HP and VP, so that we obtain the final figure. And in this figure, this distance is equal to this distance, and this distance equal to this distance, and here this distance equal to this distance, and this distance is equal to this distance. And the distances with the similar symbols marked are same. And here also VT, B dash, A dash and H dash are in the same line. HT, A, B and B are in the same line. And this angle, the inclination of AB with the true length line A to B2 gives you the true inclination with HP. And the inclination of A dash, B dash with the true length line A1, B1 will give you the true inclination with the VP. This is it.